Hello, welcome back to part two of learning as much as we can possibly learn from the VisionOS documentation created by Apple. What we're doing here is learning about creating a fully immersive experience in your app. This is a follow-up to adding 3D content to your app, which we left off in part one. In a fully immersive experience, we want to replace everything the person sees with custom content we create. The reason why we might want to create this type of experience is to offer temporary transitional experience, distraction-free space for your content, implement a virtual reality game, or present a virtual reality world to explore. Here, we have an example of how the immersive experience will remove everything and hide pass-through so that you only display what you want. It looks like here it says that the person's hands will, when it comes into view, will be shown, and that we want to use reality kits or metal to create and animate the content that we're displaying. Here, in a typical experience, in an example, I believe this is Hello World, we will be giving a person experience to use a window to turn the immersive experience on and off. That way, the user has full control over what they would like to do. Here we see a window that has arrows to make the earth and the animations move a little bit. All right, it looks like we're getting closer to writing some code. Let's look about this tip on creating fully immersive experiences first. Prepare someone for your app transition. We want to give people the control, like we said earlier, to enter or exit fully immersive experiences and provide clear transitions to and from those experiences. A clear visual transition makes it easier to adjust to such a large change. Sudden transitions might be disorienting, unpleasant, or make the person think that something went wrong. So at launch time, we want to display windows that allow a person to see their surroundings first and add controls to initiate that transition to a fully immersive experience and provide a clear indication of what the controls do. In your experience, clear controls and instructions on how to exit the experience. Here's a warning about how if you move 1.5 meters away from the initial position of the person's head, we will stop immersive experience because we don't want the user to collide with any objects. And that's a quick design tip about fully immersive experience, is creating a fully immersive experience. Next, we are finally getting to the code on how to make a fully immersive experience available to the user. And here in this code, we are in our My Immersive App protocol app. That's our main page. And here we have a window group with a content view. That's basically our window for a person to click through. Now below that, we have immersive space with an ID of solar system. And I believe that pulls the solar system view. Well, and that's the particular ID that will be opening, sorry. And the solar system view is right below that, which will open using the immersive space. And in this solar system view, we have the modifier emergence style, which has a private states var current style. I believe this is to help the user make that transition between off and on, or full or not full immersive space. And we'll start in the full immersion here. Then to open that fully immersive space, we use the open immersive space action in a button, As you can see here, here's the button solar, show solar system with a task to let result await, so asynchronous function, to run open immersive space with the ID solar system, like I said before, that matches the immersive space here. With that, we will be able to open that immersive space like in this particular example earlier. So an app can display only one space at a time, and it's an error for you to try to open a space while another space is visible. To dismiss an open space, use the dismiss immersive space action. And for more information about displaying spaces, see immersive space type. So what we want to do before we open another space is that we want to close a space. Otherwise, we would probably get some sort of runtime error. Okay, we're nearing the end of this article. This last bit is about creating content using Reality Kit and using Metal. So Reality Kit works well when your content consists of primary shapes or existing content in USD files. We'll organize the contents of your scene using Reality Kit entities and animate that content using components and systems. Don't worry if you don't understand any of these terms. We'll go over that now. Entities, which we've looked over before, are the 3D objects. The components are the items modifiers that we use to interact with the content. And I believe systems, we have not gone over that yet. We will go over it so soon, and we'll learn about that vocabulary and how its usage. Now, using Reality Composer Pro, we'll assemble your content visually, add dynamic shaders, animations, audio, and other behaviors to your content, and then display the content of your Reality Kit scene in Reality View in your scene. So we will use Reality Composer Pro to create everything we need, and we'll display it using Reality View. To do that, we'll look at this code right here by loading the Reality Composer Pro scene at runtime by fetching the URL of the Reality Composer Pro package and loading the root entity of your scene. Let's take a look at this example. This is the package file. This is the URL. This is the extension we loaded into our reality view, and then we put that scene into reality view. Let's look at that in a little bit. The next thing we can do is metal. Using metal, we can draw everything by ourselves. It sounds like we will have less hand holding here. But this is an older framework. I believe that there would be more people who are able to use this and have their own workflows to make this work. But you'll be using the compositor service framework to place the content on screen, and then the metal will render your 3D models and start drawing. And then if you want to know more, we can click this article here. With that, we have completed this creating your fully immersive experience in your app article. We have not written a line of code, but we have learned a little bit about creating a fully immersive experience. And we'll be drawing sharp layer based content in VisionOS in as well. We'll be doing this article as well. All right, so here in Draw, sharp layer-based content in VisionOS will deliver text and vector images at multiple resolutions from custom core animation layers in VisionOS. I have no idea what that means, except that we have something called core animation layers, and that will help us deliver text and vector images at multiple resolutions. Let's learn about core animation layers then. So if your app uses core animation layers directly, update your layer code to draw a high resolution version of your content when appropriate. SwiftUI and UIKit views use core animation layers to manage interface content efficiently. When a view draws its content, the underlying layer captures the content and caches it to improve subsequent render operations. Core animations on most Apple platforms rasterizes your layer at the same resolution as the screen, but core animation on VisionOS can rasterize at different resolutions to maximize both content clarity and performance. The system follows the person's eye and render content immediately in front of them at the highest possible resolution. Outside of this focal area, the system renders content at progressively lower resolutions to reduce GPU work. Because the content is in the person's peripheral vision, these lower resolutions don't impact the content clarity. As the person's eye move around, the system redraws content at different resolutions to match the change in focus. Here, we have learned nothing yet. What we can understand is that using this core animation, we will be able to save on GPU workload and be able to give the user clarity, because things that are in focus are clear and things that are out of focus are less clear and doesn't need to be. If you deliver content using custom CA layer objects, you can configure your custom layers to support drawing at different resolutions. If you don't perform these extra configuration steps, each layer rasterization its content at 2x scale factor, which is good enough for most content and matches what the layer provides on a Retina display. However, if you want to opt in to drawing at different resolutions, the layer rasterization its content up to 8x scale factor in VisionOS, which adds significant detail to text and vector-based content. In essence, we want to support custom, these use core animations to get that 8x scale factor. Otherwise, we will not be able to give the user the experience that they deserve. Okay. Request dynamic scaling for custom layers. Dynamic content scaling is off by default for all core animation layers, and frameworks or apps must turn on this support explicitly. If your interface uses only SwiftUI or UIKit views, you don't need to do anything to support this feature. SwiftUI and UIKit enables it automatically for views that benefit from the added detail, such as text views and images, views with SF symbols and other vector-based artwork. However, the framework don't enable the feature for all views, including UI views and views. It looks like we have it on by default when we use SwiftUI. However, it looks like we have to put in some work when we have a UI view or a view. If your VisionOS interface includes custom core animation layers, you can enable the want dynamic content scaling property of any CA layer object that contains vector-based content. Setting this property to true tells the system that you support rendering your layer content at different resolutions. However, the setting is not a guarantee that the system applies dynamic content scaling to your content. The system can disable the feature if your layer drawings are using incompatible functions or techniques. The following example shows how to enable the feature for a CA text layer object. After configuring the layer, set the want dynamic content scaling property to true and add the layer to your layer hierarchy. Suppose we have a CA text layer here, and we set the string to hello world, set the foreground, set the frame, and we want to set this to dynamic content scaling to true. Add that to our parent layer, and we have our dynamic content scaling working for our custom CA text layer content. Dynamic content scaling works best when the layer content text and vector-based content don't enable the feature if you do any of the following in your layer. You set the layer content using the content property. You draw primary bitmap-based content. You redraw your layer content repeatedly over a short period of time. The CA shape layer class ignores the value of one dynamic content scaling property and always enables dynamic content scaling. For other core animation layers, you must enable the feature explicitly to take advantage of it. Okay, here are times when we don't want to use dynamic content scaling. If we're redrawing it repeatedly, it's maybe too expensive. If we're doing a bitmap based content, we want it to be bitmapped. And when we set layer content using the content property. All right. This seems to be pretty important information in VisionOS when we interact with CA layer. One thing that I would like to know more about, what are CA layers and how in the world are we going to use them before we look into more information into this article. Okay, so I've pulled up CA layer, an object that manages image-based content, allows you to perform animations on that content. It looks like it's a class that's based off of Objective-C class NS object, as you can see here. This is a NS object, the root class of most Objective-C class hierarchies, from which subclasses inherit a basic interface to runtime systems and the ability to behave Objective-C as Objective-C objects. It looks like CA layer is one of those types of objects. If you haven't used them before, I don't think we will be needing them all that much. But let's finish off the article. If we ever do need them, we know what CA layers are, and we know that it's somebody who writes Objective-C is using it because they're familiar with it, and we're able to add that dynamic rasterization to it. All right, so draw the layer content dynamically. Dynamic content scaling requires you to draw your layer content using one of the prescribed methods. If you define a custom subclass of CA layer, draw your layer content in the draw-in method. If you use a CA layer delegate object to draw the layer content, use the delegate draw layer in context method instead. When you enable dynamic content scaling for layer, the system captures your app drawing command for playback later. As the person's eyes move, the system draws the layer at a higher resolution when the person looks directly at it, or at the lower resolution otherwise. Because the redraw operation implicitly communicates what the person is looking at, the system performs them outside of your app processes. Letting the system handle these operations maintain the person's privacy while still giving your app the benefits of high resolution drawing. Some core graphics routines are incompatible with dynamic content scaling. Even if you enable dynamic content scaling for your layer, the system automatically disables the feature if your layer uses any of the following: core graphics shaders, APIs that set intent, quality, or bitmap related properties. For example, don't call CG context set interpolation quality a CG bitmap context to draw content. If your app creates timer-based animations, don't animate layer changes using your draw method. Calling setNeed display on your layer repeatedly in a short time causes the system to draw the layer multiple times in quick succession because VisionOS needs a little extra time to draw a layer at high resolution. Each redraw request forces it to throw away work. A better option is to animate layer-based property to achieve the same effect, or use a CA shape layer to animate paths when needed. Okay, I don't think many of us will be needing this, and there's more on how to improve the quality at which we do layers. So the backing store for a layer consumes more memory at higher resolutions than at lower resolutions. Measure app memory usage before and after you enable dynamic content scaling to make sure that increased memory cost is worth the benefit. If your app memory usage increases too much, limit which layer adopts dynamic content scaling. You can also reduce the amount of memory each layer uses in the following ways. Make your layer smallest size possible. Larger layers require significantly more memory, especially at higher resolutions. Make the size of the layer match the size of the content by limiting padding or extra spacing. Separate complex content into different layers. Instead of drawing everything into a single layer, build your content from multiple layers and arrange the hierarchy to achieve the same result. Enable dynamic content scaling only in the layers that actually need it. Apply special effects using layer properties whenever possible. Apply effects during drawing might require you to increase the layer size. For example, apply scale and rotation effects to layer transformation properties instead of during the drawing. Don't draw your layers contents at different resolutions in advance and cache the image. Maintaining multiple images require more memory. If you do cache images, draw them only at a 2x scale factor. Don't use your drawing code to draw a single image. If your layer's content consists of an image, assign the image to the layer's content property directly. Complex drawing code can lead to performance issues. A layer with too many strokes can render quickly at lower scales, but might computationally too complex to render at larger scales. If a complex layer does not render correctly at a high resolution, turn off dynamic content scaling and measure the render times again. It sounds like it's a pain in the butt to use CA layers, and there's a lot of performance issues that you have to manage yourself from using layers based on this article. Okay, with that, we have learned everything we needed to learn from these 4 articles, hopefully, and we'll be ready to design for VisionOS in the next video.